Welcome back, everyone. Hi, my name is Benny Siegert. Today I'm going to talk to you about package stores on ChromeOS. So it's not directly running on BSD, but we're using a component of NetBSD, which is package stores, and running it on ChromeOS, which is Linux-based. But, you know, so first I'm going to tell you why we're going to do this thing, or why I'm doing this thing for myself in this way. And then I'm going to present a little bit about ChromeOS because it's quite an interesting operating system, in my opinion. We're going to be looking at bootstrapping package stores so that we can use various packages that are in there, and then some future work because, as I said, right now the work of getting package stores working well on ChromeOS is very much a work in progress, but we're going to see that. So first of all, why am I doing this? So I think Chromebooks are very attractive laptops. So you might be seeing that I'm presenting from a FreeBSD machine because this Chromebook and this long chain of adapters didn't really work together. But other than that, you know, they're kind of secure. They have secure boot on by default. Operating system images are signed. Updates are signed. They boot really quickly. They don't have a BIOS nor UEFI. Instead, they have something that's similar to Linux BIOS. I think it's called something else these days. So they, from switching it on to getting to the login screen is like 5 seconds, which is great. I've never had one break from the software. So the updates come weekly. They're installed in the background. The only thing you notice that in the system tray you get a little arrow icon, and that essentially says the next time you're going to restart your computer, you're going to have a new version, which is nice. The pricing for the hardware is often quite competitive. I like the fact that they run Android apps. So for those that don't know, ChromeOS in a sense is Chrome, the browser, is your operating system, right? But these days you can run Android apps on them, and that's super handy. For example, I'm running the FOSDEM companion Android app on this laptop, and that allows me to like schedule or look at what talks I want to see. And finally, one of those things that you either believe in or not is, you could say, it's the power of the cloud. And a Chromebook is mostly a stateless device, so it holds your account. The account credentials are Google account credentials, actually. So if you have a Gmail account, you use that to log in. But all of the settings are synced through various cloud mechanisms, and most of the data you store is going to be stored in something like Google Drive. So what that means is if my Chromebook breaks, I can get a new one. I can log in on that machine, and then I get basically an empty desktop, and then one by one, like, icons start reappearing, and the Chrome apps are being reinstalled and everything, and then like 5 minutes later, it is as it was, with the exception of things I've downloaded to the local hard drive. So that's kind of nice. However, we're going to sort of remove this property in a few minutes by installing software locally. But sure, why not? Now, as I said, ChromeOS is an operating system where the browser is the OS, or at least that's what the marketing speak says. So how are we going to get local software on this thing? There's 2 ways. There's really 3 ways. The first one is you can install something called Termux. It is an Android app that pretends to be a terminal emulator, but it happens to include more or less full Linux userland. So you can configure that, and then your software that you install is going to run in that Android thing, and you can interact with it through the graphical front end essentially, or you can set up SSH and SSH into that container or whatever you want to call it. I'm not going to talk about that. That's the way that some people use, but the thing I chose is you can set up the machine in developer mode. So developer mode removes certain restrictions, and originally it's meant for people developing the OS themselves, but we can also use it to develop software locally by installing software. And then developer mode is it used to be a hardware switch, these days it's a software switch. Like if you have a managed Chromebook, for example, if your employer gives you one, it's very likely that you're not allowed to switch that on. So that's very unfortunate. However, there's this way number 3, and it's kind of the sneak preview. If you go into crush the ChromeOS shell, you'll notice there is a very poorly documented command that's just called C, and it says run something in a container, and it's very intriguing. You can look into the source code to work out how it works. I think the idea is that you can set up a local container containing a user land, and it would be isolated enough so that you can use it even in non-developer mode. However, it requires the container to be signed in some way, and I haven't figured out how that works. And it's also not officially released, but you know, the command is there, and the source code is also there. So developer mode it is. So how does ChromeOS look internally? It's based on Linux. It's based on Gentoo Linux. That's probably the first big surprise. If you ever build Chromium OS, that's the open source version of ChromeOS. If you ever build Chromium OS from source, there's a thing called repo that'll download like various Git repos and stuff. And then at some point, like, Portage starts up and starts emerging things. It's a bit weird, but hey, it's a really well integrated Gentoo system, so why not? So on the Linux kernel, Chrome is your main userland thing that runs. There is no X server in between. There is no Wayland in between. I think Chrome runs directly on the frame buffer, I believe. The Android runtime, so the whole running Android applications locally, runs in a local container. It shares the host kernel, which is interesting. So if you do a PS in a terminal, you're going to see the typical thingamajig daemon, the kernel processes, and then there are all these processes with names like com.google.android.blah, and they're all in the same process space. So this container provides some isolation. And this isolation between users is a little bit of a figment and a little bit not. It's a bit special, as so many things. There is one non-privileged user in the system. It's called Kronos. Incidentally, Kronos is the code name that ChromeOS itself had internally before it was released. And of course, there's the root user and various system users. When you're seeing the login screen in the UI, it presents you with all the users that have accounts on the system. It's already a logged-in user session from the Unix point of view. So the Chrome that renders the login window already runs as user Kronos. And when you enter your password and you quote-unquote log in the UI, what happens is for every user that has an account, there is an encrypted file system image, and the encryption key is based on your password. So with the password you entered, it's going to mount and decrypt this file system container that contains your files. And it's going to be mounted under home Kronos user. So the home Kronos basically is all the users on the system, whereas home Kronos user, which is also set to $home, is inside this encrypted file system. In developer mode, you have virtual terminal number 2, Control-Alt F2, although F2 is really the forward arrow key. Opens a text console with a standard login. Looks fairly standard like a Gentoo system, and crush the ChromeOS shell, which you reach by pressing Ctrl-Alt-T, gains a new command called shell, and that gives you a bash. And so that's what I mainly use for working on the command line. So you're going to have a browser tab, and the browser tab runs a terminal, and in the terminal you have bash, and you can run tmux or whatever you want to run. You could also, if you don't like this particular terminal emulation, you could also set up SSH and SSH into your local machine, but you don't really need to. So that's the story about user isolation. There are a couple more idiosyncratic features of the OS that you stumble over when you use it. So first of all, the first thing I noticed is that there's no man command, and it is kind of weird. But then again, the operating system you use is not really meant to be used on a command line, so I can see them not including it. Package source whip does have a package for man. I haven't tried that out, but that in principle should work and should give you man pages. The awk command on the system, I'm going to talk a little bit more about that later, is very, very minimal and restricted for security reasons. The only editor I've found in the base system by default is Vim. And Vim is compiled with a tiny feature set, so it has no like syntax highlighting. I think it does have several buffer. I'm not sure if it has multi-buffer support, but it has no syntax highlighting, no diffing, no language extension support, no whatever. But you can edit files with it, so it's close enough. And it has a somewhat aggressive thing that kills processes that have buffer overruns. I don't know exactly how that is called, but for example, this Vim thing, when I try to build a full-featured Vim from package stores, it gets killed immediately upon startup with, there's had been a buffer overflow detected, I'm going to kill this process, and I haven't figured out why. And then the other thing is that they removed various things from the system, such as NIS, which nobody in their right mind would use, especially in 2018, or a bunch of libraries that are on the system are not delivered with headers, which again is understandable because, yeah, it's a system that you use that you don't develop in theory. And that trips up a bunch of software that essentially is badly written, that says like, this is a Linux system, so there should really be an SE Linux library with its headers, and if there's not, then it just breaks. So that's something I've tripped over a few times. Other than that, it's actually a surprisingly standard Linux userland. You're in for a surprise when you run the mount command, though. This is a tiny extract of it. In a full-screen terminal, mount is more than a screen full. Most of that is because of all those bind mounts and null mounts and whatever they're called, where you can like graft a bit of the file system somewhere else, which they use for setting up container paths and so on. And like, there's an emulated SD card in the Android container/SD card directory, and a bunch of nonsense like that. But the essential structure that I would like to work you through is on / you have this device manager device, and it's read-only. You can, when you set your machine into developer mode, you can set it into some sort of extended developer mode or whatever it's called, where everything gets read-write, and you can SSH in without a password and a whole bunch of other things. I do not recommend that. So I recommend you to leave the / partition read-only and keep it managed by the OS updater, essentially. So you're going to keep getting these weekly updates, and every time it's going to just do random things that you don't care about in the / partition. And you can even, once you're in developer mode, you can re-enable secure boot, because it by default gets disabled. And and then your operating system images are verified, which is good. The other thing, the other two important partitions are the one that's called stateful partition, and that is read-write, and the OEM partition, which on my machine has almost nothing. So the manufacturer of the Chromebook can put their own crap in there. And the stateful partition is the one that holds the encrypted file system image for all the users. They're just, loopback mounts on that partition. And the stateful partition is also the thing that is wiped when you, as they call it, power wash the device. And it's the thing that has the main part of the internal storage. So the slash is relatively tiny, and most of it is on the stateful partition, so you can use it for your data. So you see home Chronos user, that's the encrypted file system thing. User local is one of those bind mounts. One thing to notice is that your home directory is no SUID, no def, and no exec. So developing inside there is no fun. However, the only bit of the file system that is exposed to the UI of the local file system is the downloads folder under your home. So what I do is I have a home Chronos user downloads source where I put all my source trees, so I can use like GUI editors and Chrome apps to work on those. But if I want to compile something, then I need to put in some sort of temporary directory or package source. All of it is in user local for me. So here's my recommendation. As I said, leave the root partition read-only, play around in user local or the stateful partition, which is the same thing really. Or you might choose to put an SD card or something, or even a USB stick, into your laptop and format that as X2 and mount it without no exec, and then play in that. Maybe that's also sensible, because you can make a very large SD card these days.
Could you jump on the bind mount bandwagon and just bind mount stuff into place to have like conventional parts?
You could probably. I haven't tried that, but package source is not very opinionated. It allows you to install it anywhere, so that's nice. So now let's jump to package source actually. What is it? It's the NetBSD package collection. And at the time of writing, we've passed the 20,000 package mark, which is quite a lot. So these packages are, the main part of package source is essentially a large tree of make files that encode how to build all these packages, how to, what their dependencies are, like what packages you need to have installed before you can even try to build, and so on and so forth. Package source is released once a quarter, every 3 months. The last release was called 2017 Q4, was around the New Year's Eve. These releases are kept up to date with security updates, although I'll show the stuff I'm going to show you later is all on package source current, unfortunately. In principle, it has the possibility of using binary packages or building things from source. However, because this is a new platform, there are no binary packages yet. Package source itself supports 20 different OS types and several variants, and a whole bunch, basically any architecture that those OSs might run on. One thing I forgot to mention, ChromeOS itself has 4 different architectures. It has essentially 32-bit x86, 64-bit x86, and then ARM in 32 and 64 bits. So this Chromebook over there is the Samsung Chromebook Pro. Is AMD 64 architecture. The Samsung Chromebook Plus is a 64-bit ARM. So you have all the variants. I've only tested AMD 64. Challenge number 1, when you want to build stuff, where do you get a compiler, or rather, where do you get a tool chain from? So ChromeOS has a command in dev mode that's called dev install that's supposed to install tools for you to develop. But however, it installs a whole bunch of crap like Ruby and Python and like scripting language nonsense, but no C compiler. And they somebody asked on a mailing list, like, what is this? And they said, we're working on it, but we don't have anything yet. So that's bad. If this were an ideal world, we would have, somebody else, for example me, would have already built binary packages for, say, GCC. So you could just install a binary bootstrap kit, add the packages, and have a tool chain. However, I'm not at that point yet, unfortunately. So we're going to need some sort of a bridge to get a C compiler now that we don't have one yet. So I found there are different things that you might try. I found this thing called Chromebrew. And it's pretty intriguing. It's based on Homebrew, except for Chrome. And it's written in Ruby because it's Homebrew based. And you install it with this fun command, like just wget a thing and pipe it into bash, which I did. And its redeeming feature is that it has binary. So this is the homepage of Chromebrew. It has binary packages available for all 4 Chrome architectures, ChromeOS architectures. So that's nice. It's GPL licensed. So good shout out to them. They're quite a bit further down the rabbit hole than I am. So installing, once you've installed Chromebrew, like you pipe this command into bash. You use the command called crew, install GCC and Linux headers. It'll say it needs to install various other things. Then it says, oh, look, there's a binary package available, downloads the things, installs. It's actually really nice. Now we're going to do the following. We're going to download the package source current tarball from the package source FTP, extract it in user local. As I said before, you enter shell to enter the shell, and then you change into the bootstrap directory and call the bootstrap script. And it immediately exits and says, your shell's echo command is not BSD compatible. Oh, look, you should have another shell. It turns out if you export bin bash as your sh, it works. Doesn't seem particularly BSD, but okay. So try to. This is the bootstrap command. This is actually try 10 or something. This is the command line I settled on. I'm going to explain to you what all those parameters mean. The first one, unprivileged, is really nice. It'll install everything as user Chronos, so you don't have to use sudo all the time. You might like that or not. I do. Then the next thing is the installation directories. So I said the source tree I unpacked under user local package source. I use user local package as the prefix, and then I put the var and package db inside that prefix. So everything is nicely self-contained. You can back up user local pkg and have your entire installation there. Then C-wrappers equal no is a fun one that took me a while. So C-wrappers is, it's kind of hard to explain even, is a package source uses a set of wrappers around things like a compiler, the linker, and so on. And it can do various things such as adapt the command lines to different versions of compilers. You can tell it to like remove things from the command line. Like if the build system insists on adding, I don't know, -p thread and you don't want it, you can tell it to remove that parameter. And so there's two implementations of the wrappers. There's the old ones, the old and busted ones, they're written in shell, and the new hotness is written in C. It's quite a bit faster too. However, because of the way the bootstrap detects the presence or absence of various things, it detects there's no patch command, which is true. So it installs diffutils. And diffutils depends on a whole bunch of other things. And so it ends up creating a circular dependency where to install C wrappers, you need to have diffutils installed, but to build diffutils, you need C wrappers installed. So you bootstrap without C wrappers, and then you delete, once you've bootstrapped, the line that says C wrappers equal no from your makeconf, and then the rest will be built without. And then prefer package source equal yes, because the libraries, as I said, that are delivered by the base system are often incomplete in various ways. And here I put 6 jobs. This machine has 4 threads, so 6 make jobs is a good way of getting the maximum build performance out. And then this happens on Chrome Beta, Chrome 64 and later. It'll run happily for a while, and then it says I'm going to install the bootstrap MK files, and then you get this fun message, AWK runtime error pipe execution not allowed in sandbox mode. You go, what the hell is this? It turns out the AWK that ChromeOS delivers has been used in an exploit as a vector of running a command. And I don't know all the exact details, but you know that there is this thing called pwn to own or something, and ChromeOS regularly has good performance, sometimes not so good, and one of those exploit chains that did the full compromise of the system used awk. So they said, we're going to fix that, and they implemented the sandbox mode for mock, which is their awk, and they install a version of awk that is permanently set into the sandbox mode. So it cannot do networking, it cannot run pipes, it cannot open files with programmatic names, and so on and so forth, which is kind of annoying because the dependency management of package source needs those features. So I fixed it on Friday in the train. Essentially, just the bootstrap kit now detects that you're on Chrome OS and sets needs awk equal yes, and then we build a netbsd awk, and everything is fine. The other thing I did in this work is to properly support Chrome OS specific hacks customizations by making it a sort of first-class citizen in package source. Package source has the concept of an OS variant, and that was invented for Solaris derivatives or Sun OS derivatives. So you might know there's like, there's Illumos and Open Indiana and a bunch of others. So they are distinguished by setting this OS variant variable. So now in package source current on Linux, we essentially put the lowercase distro name in OS variant, and so you can check if OS variant equal Chrome OS, then you put some customization. Some things that break on the platform when it's upstream's fault, I try to send patches upstream. There have been a couple ones where I did that. So back to our little use case. Now that we have installed package source, we can install some software. First of all, you want to add this path thing at the end of your bash rc, so that all the commands you install in package source are available from the command line. Then you can just go to any old directory, such as lang/go, my personal favorite. Do bmake package install. It'll download the sources, check for dependencies, install those first, then download the sources, build everything, install, and create a binary package. You can take those binary packages and move them to other machines. It's all nice. If you go to pkgsrc.se, it has a searchable web catalog of the 20,000 plus packages. So once you find something there, you can just install and use. And in my last 40 seconds, I'm going to quickly summarize the future work for this. And I also want to say we're open for contributions. So if you have a Chromebook and you're interested in joining this effort, please get in touch. We have a debug tracker, and we have a GitHub even, although it's a read-only mirror. My first point that I want to fix is I want to have a full tool chain as package source binary packages. So that means binutils, GCC, and so on. And then we can get rid of the Chrome brew requirement and you'll just be able to download a bootstrap kit and binary packages. And I want to package some things that are not in base. So again, there's some software that thinks if you're on Linux, you must have POSIX extended attributes. However, the library is not there on ChromeOS, so you can add those via package source. Man is another example. And finally, look into support for X applications. So as far as I understand, you cannot mix graphical X applications on the ChromeOS desktop, but I think you can launch an X server on a new virtual terminal, such as VT3, and that should work in the future. And that's it, and we don't have time for questions.